There are 5 main types of chemical reactions: combustion, synthesis, decomposition, single displacement, and double displacement. Combustion reactions. This type of reaction requires 3 things: fuel, which is a hydrocarbon molecule made up of hydrogens and carbon atoms, oxygen gas, and a heat source. There are 2 main types of combustion reactions. Complete combustion is when there is enough oxygen for all of the fuel to burn, and the only products are carbon dioxide and water. In incomplete combustion, there is not enough oxygen gas, so carbon monoxide and carbon soot are also produced. Carbon monoxide is poisonous. This is an example of a complete combustion reaction of methane gas. Synthesis reactions are also known as combination reactions because 2 or more reactants combine to form one single product. Sometimes one of the reactants is oxygen gas, reacting with a metal to produce a metal oxide, as in the second example. We will consider this to be a synthesis reaction and not a combustion reaction. Again, 2 reactants combine to form one product. A decomposition reaction is when a compound breaks down into 2 or more simpler substances. It is the opposite of a synthesis reaction. It involves one reactant breaking down, decomposing into 2 or more products. For example, sodium chloride decomposes to produce sodium and chlorine gas. Or sodium hydrogen carbonate decomposes to produce sodium carbonate, water, and carbon dioxide gas. Again, one reactant breaks down to produce 2 products. Single displacement reactions. This reaction involves one element with a compound as reactants. The single element will replace an element within the compound to produce a new element and a new ionic compound. It is often based on an activity series of reactivity, which means the single element in the reaction must be more reactive or higher on the activity series than what it is replacing in the compound. Take a look at page 126 of your textbook. For example, zinc reacts with silver nitrate. Notice how the zinc replaces the silver to form zinc nitrate as a product and a single silver element. Double displacement reactions are probably the most complicated reactions we will study. They involve 2 ionic compounds as reactants that turn into 2 new ionic compounds as products. There are 2 types of double displacement reactions: precipitate reactions and neutralization reactions. A general example of a double displacement reaction would be aqueous sodium chloride reacts with aqueous potassium nitrate to produce aqueous potassium chloride and aqueous sodium nitrate. Notice the sodium and the potassium switch spots. Precipitate reactions. A special type of double displacement reaction where one of the products is an insoluble ionic compound in water, therefore forming a precipitate. We will need to use a solubility table to determine which product is insoluble. The subscript S is used to represent the precipitate, whereas AQ represents the ionic compound that dissolves in the water. For example, aqueous potassium iodide reacts with aqueous lead 2 nitrate to produce solid lead-2 iodide and aqueous potassium nitrate. The lead-2 iodide is a precipitate. It's insoluble in water and forms, like we saw in class, a yellow precipitate. The second type of a double displacement reaction is known as a neutralization reaction. In this case, the reactants are an acid, which is something that will release hydrogen ion in solution, and a base, which will release a hydroxide ion. The products of a neutralization reaction are always water and a metal salt, or simply an ionic compound. For example, hydrochloric acid reacts with sodium hydroxide to produce water and sodium chloride. The hydrogen and the sodium will switch places. Think of water on the product side as simply being an HOH. This might make it easier to see how a neutralization reaction is still considered a double displacement reaction.